Students, in this video we are going to learn about how to do the problems in center of mass. Here the first problem goes like this, students. Was the board. Let's say it is a circular plate. Okay, students. The circular plate has uniform density. Okay, students, which has a radius of r. The problem goes like this. From this kind of circular plate, it has uniform density and as well as the uniform thickness. We will remove another circular plate from this, which has different radius when compared to this. Okay, he will ask you, what is the position of the center of mass? Or he will ask you, find the shift in center of mass. The problem goes in this way. Okay, if you watch the board carefully, you will find a circle there. Actually, I am representing a circular plate which has uniform thickness and as well as made of the same material, has the uniform density. Here is a circular plate. Let's say the radius of the circular plate is r, students. The students, obviously it is equal to r. Here, imagine that we remove this portion from the circular. What's that? From the circular plate. Okay, he is asking us, what is the shift of the center of mass? And you learn that center of mass always shifts towards the heavier part. If you remove this portion from this, here, this is the portion what we are removing, students. Okay, it is the removed part. We are going to remove it. Okay, students. And it is the radius of the removed part. Means what? This distance is half of the radius. See this. This one is half of the radius, the circular part radius. Let's say this plate has a mass of m1. Obviously, it has a mass of m2. Okay, students. We have to find out the shift in center of mass. If you say it's the origin, and you learn that the center of mass of a regular shaped body is always located at the geometrical center only. Obviously, if you didn't remove this part from this, the coordinates of center of mass, either xcm or ycm, they are 0, 0 only. But what we are doing here, we are removing this mass. So obviously center of mass will be shifted. It is somewhere lies here. Then we have to find out the exact location. And you have learned that to find the center of mass, we have an equation. xcm is equal to m1 x1 plus m2 x2 upon m1 plus m2. Maybe you observed the same thing in my previous video. Okay, center of mass of two body system. If you didn't watch it, please go and you will find. It is the center of mass for a two body system, students. Here we have to find out the mass. I said initially it has a mass of m1 and the removed portion has a mass of m2. Removed, we are taking it as the negative mass, students. It is a just assumption. We won't get any kind of negative masses, but to make the calculations easy, we are taking this mass as the m2. Okay, students, and he also saying that this material has uniform density. And you know that the relation between the mass and density. We are taking the thickness very small, that's why I am neglecting that term. And you know that density is equal to mass upon volume. Okay, or density is equal to m by v. I am writing here, or m can be written as m is equal to rho v. Okay, students. Here m can also be written as rho into volume. Volume is what? Area into thickness here. thickness is constant. That's why I am relating it as m is proportional to A. It is the constant, it is one more constant. A is the area of cross section. It is a circular plate, and you know that area is equal to pi r squared. Getting me, students? Means what we can write? The mass can also be written as pi into r square, where pi is another constant and mass is proportional to r square. Mass of the plate is directly proportional to the square of this radius. Okay, students? See, I am taking it as the first mass. That means m1 must be written as m1 is proportional to r square, and I am taking the mass this one. That is m2 is proportional to, see, the radius of the plate is half of this one. I am writing it as r by 2 whole square. Okay, students? We have the masses. Then after we have to take the positions, location of the particles x1 and x2. x1 is equal to 0. Just imagine the mass is not removed and its center of mass position is x1, that is O. And similarly we have to take the x2. x2, it is the distance. It is equal to r by 2, sorry. It is r by 2. Just substitute the values in, students. We will get xcm is equal to m1 x1, m2 x2 upon m1 plus m2. In the place of m1 we are substituting r square, that is r squared into x1, it is 0, okay, plus m2, it is r squared upon 4, okay. It is negative mass, I said. That's why I am writing it is r square by 4. I am considering it as the negative, and obviously it becomes as negative. Okay, into x2, it is r by 2. Here we have upon, okay, students, m1 r square minus r square by 4, and it can also be written as minus r squared by 4 multiplied with the r by 2 by 3 mr squared by 4, where 4 get cancelled and r square get cancels, and what you get, it is minus r by 6. Okay, it is the shift in the center of mass. It might be somewhere. Okay, first it is here and it is shifted. Then what about the coordinates of center of mass with respect to the y-axis? As you know that ycm is equal to m1 y1 plus m2 y2 by m1 plus m2. Here we don't have any shift in y-axis. That's why the coordinates of center of mass with respect to y-axis is 0. Okay, students, in this way you can calculate the center of mass. That means shift of center of mass. Let's do one more problem, students, which depends upon the same concept what you did right now. Here in this one, in this example, what I am taking, in example, let's take the radius which is equal to 6 centimeter. Okay, students, and the removed part, you say it has the r1 and it is r2. R2 is equal to, as I told before, it is 3 centimeter. Okay, we have to find out the center of mass, students. Say this, xcm can be written as m1 x1 minus m2 x2 upon m1 minus m2. Okay, students, we have to put the values there. Okay, we'll learn that m is proportional to r squared. That's why m1 is proportional to r1 square. 6 squared, 36. m2 is proportional to 3 squared. It is 9. Okay, students. And also we have to take the x1 and x2. Obviously, x1 is equal to 0 and x2 is equal to 3. It is a 3 centimeter. Just put the values there, students. We will get xm is equal to m1. Okay, m1 is equal to how much? 36 multiplied 0 minus 9 into 3 by 36 minus 9 0 minus 27 by 36 minus 9 minus 27 by 27. Okay, 1 centimeter. The center of mass shifted to 1 centimeter right side, this left side, students. And similarly, the YCM, there is no change in, it is equal to 0. In this way, you can find out what is that the center of mass when a plate is removed from the circular plate of given radius. Let's do one more application, students. In this one, in previous problem, we removed the circular plate which has the radius which is half of the radius of this circular plate, students. Now, I am removing another plate from one of the edges. Okay, students. Here it is r by 2 and this entire length, it is also r by 2. Maybe the diagram is not well. Okay, students. This portion we are removing. How the center of mass will change? Okay, students. It is the r by 2 means what? This part is r by 4. Okay, students. Okay, we have to use the same here. It is m1 and it is m2. Okay, students. Here it is r by 2 and it is r by 4. First we have to go with the same procedure what we followed there. Okay, students. First we have to find out the mass. m1 is proportional to r squared we had. Okay. Then we have to find out the m2. Okay, that is r by 4 whole square. m2 is proportional to r square by 16, students. Then after we have to find out the x1. x1 is equal to 0. Okay, then we have to find the x2. x2 might be equal to r by 2 plus up to here. This is the distance x2. Okay, students. r by 4 it is 3r by 4 and remaining is easy, students. Let us substitute the values. xm is equal to m1 x1 and the second mass is negative minus m2 x2 by m1 minus m2. Just substitute the values in. That is xm is equal to m1. m1 is proportional to r squared and x1 is 0 minus m2 is r squared by 16 into 3r by 4 upon m1 is r squared minus r squared by 16. It is minus r squared by 16 into 3r by 4 divided by 16r squared. 15r squared by 16. R square and r square 16 get cancelled, students. But we have minus 3r by 4 by 15. That is minus 3r by 60. Okay students, 3 1s are 3 20s. That is minus r by 20. Okay, it moves here. Okay students, similarly you can find out the YCM as 0. It is the way to solve these kind of problems, whatever the position of the removed plate. Okay students, let's see one more problem which is similar to this. Okay, I'm taking the same. I hope you followed this problem. Just we have to find out the masses, then the things will be easier for you. See the students here. It's a circular plate. Okay students. Okay, this time what did happen? Another plate is removed from this, from its center exactly. Okay students, this is the removed part. Then what would be the center of shift in center of mass? There is no shift in center of mass. The coordinates of center of mass, xcm is equal to 0 and ycm is equal to 0. Since it is a ring, since when it is removed and it behaves like a ring, maybe it is r by 2 or anything, r by 4 or any. If you remove a part from the center, then it behaves like a ring, and you learn that there is no need of center of mass to be present in the at the center. That's why the geometrical center or the centroid is the center of mass of ring. That's why the coordinates of center of mass is equal to 0. Okay students, let's do one more. See. Okay students, this time instead of the circular plate, I am taking a sphere. Let's say it is a sphere which has the diameter of d and radius is r. Okay students, it is the sphere. How do we find the center of mass? And you know that density, the same what I told before, the density is uniform, that is the d, and radius is r. Density is equal to mass upon volume. We said mass is equal to rho v. It is a sphere. You know that volume of the sphere is equal to 4 by 3 by r cube. Okay students, here m can be written as rho into 4 by 3 by r cube students, and mass is proportional to r cube. Okay students, this is the relation when if we gave it as a sphere. The same story is happening. From this sphere, another sphere is removed from one of the edges. Okay, it has the radius which is equal to half of the radius of the sphere. Okay students, now it turns into the first mass and it is the negative mass. Okay students, then we have to find out the masses. m1 is proportional to r cube and m2 is proportional to r by 2 whole cube, since it is half. Then m2 is proportional to r cube by 8. Then after we have to find out is that x1 and x2. It's a center, geometrical center. x1 is equal to 0 and this distance is x2. x2 is equal to x1 is equal to 0 and x2 is equal to r by 2. Just substitute all the values in students. What you get? We have the relation xcm is equal to m1 x1, negative mass it is m2 x2 upon m1 minus m2. Just we are substituting the values. XCM. M1 we have r cube into x1, obviously it is 0, minus m2 r cube by 8 into x2, it is equal to r by 2, by m1 r cube minus, okay, m is proportional to r cube, it is m2 r cube by 8, it is 0, minus r cube by 8 into r by 2 by 7 r cube by 8, and it can be written as minus r cube by 8 into r by 2 by 7 r cube by 8. Wait, 8 and r cube get cancelled, and what you get, it is minus r by 14. The shift in center of mass is minus r by 14. And what about the YCM? The same happened before, it is equal to 0. Here if you put any numerical r as 2 or 4 or anything, you will get the results in that way. My suggestion is, students, just remember mass is directly proportional to the radius, okay, the powers we are going. If you take the circular plate, plate means what, area is pi r squared, then it becomes m is proportional to r square. It is a sphere and we have to take with respect to the volume, that is 4 by 3 pi r cube, that's why we took it is r cube. Okay, students, let's do one more example which is on the same concept. Here this time, instead of the plate, we took a square plate, students. Let's say the square plate has uniform thickness and made of the material of same density, okay, as a square plate, students. Say is a square plate has a length of L and its breadth is also equal to L. What is saying in this problem? He is asking us, if a plate is removed is from one of its corners, okay, here in this way, this is the removed mass, okay, this is removed, which has a length of half of the length of the plate and breadth which is half of the length. Then he is asking us, what is the shift in center of mass? I hope you understood. It is a square plate, students, which has thickness T. It is made of material of uniform thickness and as well as it has the uniform density. Its length is L and its breadth is L, since it's a square plate. And a plate is removed from this. It is from one of the edges. Either it is from here or here or here or here, anywhere. He is asking us how the center of mass will shift. First we have to locate the center of mass. Obviously it is, before we removing, a geometrical center is the center of mass, as you know that. For regular shaped bodies, center of mass is a geometrical center only. That's why we took the coordinates as x1 is equal to 0 and as well as y1 is equal to 0. Okay, students, then after we remove the portion from this one, then how, okay, the center of mass will change, we have to find. Okay, students, it is the line which is passing. I'm not good in drawing, okay, actually, okay, I have to take it as like this and everything is fine now. Say it is A, it is the B, it is the C and it is the D. Okay, students, here its center of mass obviously at the geometrical center only. Let's say, okay, it is the O dash and it's O dash and O dash. Okay, students, see, we have to find out, we took x1 as equal to O and we need to find x2. x2 is O, O dash. Okay, students. But we don't know the value of the O dash, this length. Okay. Here it is a right angle triangle. What's this? Okay. In that triangle, we can write dB squared is equal to hypotenuse adjacent AD squared plus, say it is it is B, AB squared, and substitute the values. dB squared is equal to AD squared, it is L square plus L square, it is 2L squared, and dB is equal to root of 2L square, that is L root 2. We have this entire length is equal to dB. Then see, it is the half of the length and it is passing, it is 1/4. OO dash is 1/4 part of the dB. Okay, students. Then we measured it as OO dash is equal to L root 2/4. Okay. That is, we got OO dash as L root 2/4. Let's take the mass first. This one, after removing, say it is a M1 and it is M2. M1 is directly proportional to area L squared, and M2 we have to find is proportional to, see this L/2 and L/2. L/2 whole square, that is M2 is proportional to L squared by 4. Okay, students. We had M1 and as well as the M2 and X1 and X2. Next we have to substitute the values in. Then we get XCM, as you know that it is M1 X1 plus M2 X2 by M1 plus M2. Okay, students. Or it can be written as XCM is equal to M1 X1 minus M2 X2. We are considering the removed mass as the negative one. Okay, students, by M1 minus M2, that is M1 we had is L square, and X1 it is 0 minus M2 L square by 4 into X2. What we have? L root 2/4 by M1 L square minus L square by 4. It is minus L square by 4 into L root 2/4 by 3L squared by 4. For 4 and L square get cancelled. What we have, students? It is minus L root 2 by 4, these are 12. Okay, students. It is XCM. In this way you can find out the center of mass, and similarly you will get the YCM also. It is equal to 0. If you put the numericals in, and you will get the result. Okay, if you want to do, just put a numerical, and do remember this. Those who are going for the competitive examinations have to remember this equation. Simply will get the answer, and maybe the question will be asked from the center it is removed. Obviously you have to say the center of mass is 0 itself. This plate, instead of here, from the middle they removed. How the center of mass will change? The simple, it remains there only, since it is a regular shaped body. Here we are taking one more example, students. In this time we are taking a rectangular plate. It is the rectangular okay, students. This rectangular plate has a length of L and breadth of B. Before we did a problem, in the case of a square plate, just dimensions have been changed, and it has the uniform density and as well as has the same thickness. And from this portion is removed, students. Okay, this is removed, which has the length which is equal to L/2 and it is equal to B/2. Okay, students, we are writing with respect to L and B now. And as you know that before was that we removed this portion, the center of mass lies at geometrical center, then you can write the coordinates as x1 is equal to 0 and y1 is equal to 0. Here the same thing will happen. Once again, the center of mass always shifts towards the heavier mass. Okay, in this case. Okay, students. Okay, and if you take this one, it is a rectangular plate. It shifts towards the heavier mass. Let's name it as AB, C, D as the center, and the center of mass shifts here. Say it is O dash. Again, we have to find out what is that x2. It is x2, students. It is x1. x2 is equal to O dash again. Okay, and y2 is obviously it is equal to 0. Getting me, students? Then we have to write the mass. You know that mass is directly proportional to area. That's why m1 is proportional to LB. Okay, students, and m2 is the m1, and m2 it goes with the same ratio, L by 2 into B by 2, LB by 4. Okay, students, we had, and just we had to substitute in the relation XCM is equal to m1 x1 plus m2 x2 upon m1 by m1 plus m2. Since it is the negative mass, as a positive we are putting the signs. XCM is equal to m1 x1 minus m2 x2 by m1 plus m2. Okay, and we need to find the O dash. Okay, students, this is m1 minus m2. Okay, in this rectangle we get a triangle here, that is dv squared can be written as what, dA squared plus AB squared. Same procedure we are following. It's the length and it's the breadth. dA is the breadth B squared plus L squared. That is dB is equal to under root of L squared plus B squared. Okay, students, and we need to find out the O dash. Obviously it is fourth part of that. O dash is equal to dB by 4. It is root of L square plus B squared by 4. Okay, and you know that it is equal to x2. Just we are substituting the values in. What we get? XCM is equal to m1. m1 we had, it is LB into 0 minus LB by 4. Okay, students, into x2 we had under root of L square B plus B squared by 4 by m1 LB minus LB by 4. It is minus LB by 4 into root of L square plus B square by 4 divided by 3LB by 4. Okay, students, where 4 get cancelled and LB. It is minus under root of L square plus B squared by 12. Okay, students, in this way you can find out. Let's check whether it's right or wrong. If you consider it as a square plate, then what you get? L is equal to B, L square plus B squared. Okay, 2L squared, L root 2 by 12. Okay, same results we will get. L, where if see L is equal to B, then it turns into a square plate, then what you get? Under root of L square plus L square by 12. It is minus root of 2L square, that is minus L root 2 by 12. The same result what you did before. I hope you understood how to solve these kind of problems. Okay students, I hope you understood how to solve the problems in case of the center of mass, that too about the mass is removed from a regular shaped body. It is the first part of the examples in center of mass, students. In second part, we continue it. Here in that one, you will learn about how to locate the center of mass of different shaped bodies like L. If it is T, here they go with the same relation, and as well as when the structure is like this C. Okay, we have the different structure, students. If the structure is just like E, okay, in this one we will get the two cases. It's like this, or if it is extended, all goes with the same constant. Okay, same thing. And also if the structure is like F. These structures we will learn in the second part of the video, students. Okay, soon in 2-3 days it will be posted. Do watch my video channel, students. If you like my videos, don't forget to subscribe my channel and suggest my channel to others, those who want to learn physics. Thank you for watching my video, students.